So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So before we get started, let me quickly introduce myself to you all first. So my name is Neeraj Kheria, and I have been working in the IT industry for more than 13 years now. So the main agenda for today's session, we are going to first of all discuss on what exactly we mean by version control system. Then we are going to talk about Git and GitHub. Then we are going to talk about the installation for Git and setup, how we can configure it. And then we are going to talk about the Git operations and commands available. So that is going to be our agenda for today's session. And towards the end, we are going to see a small hands-on top of Git as well. So let's get started. Now, if we are for example, if you talk about the version control system, now for every changes that we are doing when we are working on any solution or any, for example, we are developing a website or any application, there are multiple changes that are done on any file, on every file, correct? Because at the end we create something, then we modify, then we keep on, as a developer, we keep on modifying the files by adding codes, by modifying the codes, by deleting some sections as well. This is currently an ongoing process, correct? And that exactly is why we have to make sure that when we are doing endless number of changes, we do need to have a system that can track all the changes that we are doing on the files, correct? For example, let's suppose there are 3 developers, those who are working remotely on a web application. Let's say we have now these three, one developer is sitting in Sydney, the other one is in Singapore, and the other one is Mumbai, and they all are working on a same project. Now they all are working on the same project. That means they all are working on, again, one is working on streaming page, the other developer, they are working on user information page, and the third developer is working on the payment page. Correct? They all are working on different pages. All right. And they all are submitting the codes at different point of time as well. Now, when we have developers working remotely, so basically we need to have a system so that they can collaborate together. They can collaborate together. So basically we can allow different versions to be updated as well, because at the end, when these team members are there working on a single project on different pages, they will be uploading, they will be making multiple changes to the code as well, correct? That's natural. So they will be making multiple changes, they will be testing something, and that's why we have to ensure that we keep a track of every changes done in these different files. And that's why we do have to have something called as version control system. For example, at 11 o'clock, there was a modification done where we have added the user info page. And then on, suppose at 12 o'clock, there was another update that we have modified the add payment page. So again, when we have multiple changes being done on a single application or to any file in the same application, then for tracking all the changes, we do need to have something called as version control. So basically, it's a system that records all the changes to the files and then or a set of files. And these versions are basically recorded in a repository, and then they can be recalled from the same. And basically, there are 2 types of version control system. We have centralized, we have local, and then we have distributed version control system. We have 3 main types: centralized, we have local, centralized, and distributed version control system. Now, to understand what exactly these are, let's talk about these in simple layman terms. Just a moment. So for doing that, we can come to our annotation mode. We can move to our annotation mode to have a further clarity. Let's say to understand the concept of changes. For example, let's say when we are working now, when a developer is working on, let's say a simple HTML page, the developer is working on an HTML page. Now, initially the developer has defined a division tag on this in this HTML page, followed by a simple paragraph, and then the images available in this particular HTML page here. Suppose this is the first copy that we have given to the client. Now let's say after, suppose we have been making multiple changes. For example, let's say in the second copy, the client requested for some changes. Now in the second copy, first of all, they have asked us to enter H1, then again add another H2 line, and then add the division afterwards. Suppose same way in the third copy, in the third revision, the client has asked us to add the, suppose add the image first, then followed by a division, then followed by a video. Suppose they are making multiple changes. And same way, there can be n number of changes that can be done on a single file. There can be n number of changes, correct? Now, let's say after 20 different modifications, now the client has requested that to restore the 10th copy that we have given to them. All right. Or let's say we want to restore the application to a previous version so that we can copy the code that we have saved in that particular version so that we can reuse the same component in our later versions. So if we are not saving all the changes, then we won't be able to go back to that code, correct? And that's why we make sure that we make use of something called as version control system, through which we can keep a track of every changes that we are doing on any file. For example, suppose there have been multiple changes being done every once in a while. So every change can be saved as a version. So here it can be version 1, version 2, version 3, and there can be n number of versions that we can store for any specific file as a part of version control system. And version control system simply assigns a unique version ID to each and every file changes. And if you want, we can also compare the versions so that we can see what exactly has changed in the same file. We can do that particular comparison. Now, in terms of the type of version control system, there are two main types. We have centralized and then we have distributed. So for example, we can say in terms of the version control system that we call as VCS. So there are two types. First of all, we have centralized and then we have distributed. So in terms of centralized, what happens? Or we can say we also have another one as local. So if we talk about the local one, for example, suppose if we have multiple team of developers, they are working on the same project. For example, we have developer 1, developer 2, developer 3, and 4. There are 4 different developers working on the same project. Now, developer 1, suppose they are working on their own workspace. So their own system is referred as workspace in which they work on. And now suppose once they are done working on any particular, for example, they have 5 files to work on. And once they are done with one file, then they store the copy of the final changes in their own local system. And that is what we refer as a local version control system. Then we have these centralized, for example, once the developers, they are done. These developers, they are done working on their own workspace, once they are done with the code, then they can upload the code directly to a centralized centralized remote repository. So we can say this is what? This is basically a remote repository stored somewhere on the internet and this can be of any service provider. For example, if developer 1 is done with the code, then they can simply commit their code. That means they can push the codes to the centralized repository so that whatever changes they have done, they can be stored in a centralized repository in a centralized location. And basically, this is not available locally. This is a remote repository that we can get connected via internet, and then we can start storing all the files in this centralized repository. So that is, suppose if we have a project manager, then they can have the access to all the codes and all the development work done by the entire team, so that it becomes much easier to manage the entire code in a centralized directory. And this is what we refer as centralized version control system. When we have a team of developers and they simply commit their codes directly to a centralized repository, a centralized remote repository, then that is called as a centralized version control system. And then we have distributed. So in distributed, what happens? Suppose the team is done developing, they're working on the code. So now once they're done working on the code, then instead of pushing their code directly to a remote repository, what they can do, they can store the code, whatever they have worked on, they can store their code in their own local repository first. So for example, if we have made 5 different changes to 5 different files here, they can upload all the changes and store them in something called as local repository. We have something called as local repository. So all the changes done by the developers, they are going to store locally first in a local repository. And then, for example, we want to update the center repository as a specific interval or a specific time. Then we can update the entire center repository by using a single push where all the files are going to be stored and in a remote repository by different local repositories defined for different workspaces. And this is referred as distributed version control system. So basically, for any reason, let's say if remote repository is not available, it is not accessible, then still developers, they can continue to do their work by submitting the code to a local repository, which you can later on push to remote repositories wherever they are, whenever they are available. That is what we mean by distributed version control system. Let's erase this up. All right. So this is what we have discussed. We have a local VCS and then we have centralized VCS where we have multiple teams. They are pushing the code to a centralized repository, and then we have distributed where the developers, they first of all push the code to a local repository, and then the code gets pushed from local to the centralized. That's how it works, and that exactly is what we discussed as a part of our hands-on as well. All right, so now let's discuss on why version control system. We had seen that it allows the shared workspace infrastructure so that we can have all the team members, they can simply update the code to a centralized repository. And again, if they want, they can also pull the codes submitted by other developers as well for a quick reference. They can do that. And using the version control system, we can manage the versions, and then we can also go for rollback. Suppose if we have made some update to the code, and suppose if the updated code is not working well with the other components, then we can simply go for rollback. That means the last known configuration can be restored as part of the requirement. And then we have it's simply reduce the downtime. That means it can reverse faulty updates and save time. And then it can be used to analyze the project as well. That means we can use it for analyzing and comparing different versions as part of the requirement. Now, if you talk about repository is basically a centralized directory, we can say that. Repository is like a centralized directory in which we can allow the team members, or we can say we can allow anyone to submit and store the code. And that exactly is what we have termed as repository. So we have discussed it. There is a local repository, so developers, they can continue to push their codes to a local repository and distribute it. And once they are done, they can push the codes to the centralized repository as well once they are done. So a repository is more like a directory or a storage space where we can store all our projects, and it can be local to a folder on a computer, or it can be a storage space on another online host, like we have GitHub. So GitHub is the most popular online repository that we can make use of. And then we have centralized and distributed. So we have seen in centralized, we have multiple workstations, and in centralized, the work is directly updated. It is directly updated in the centralized repository itself. We have seen that. And suppose if anyone wants to fetch the code, they can simply fetch the code from any of the servers as well. And then in distributed, first of all, the workstations, they commit. That means they simply update the code to a local repository first, and then the code is then being pushed from local to the centralized repository so that we can store the data in a centralized repository with the work done by multiple developers. Now, if we talk about Git and GitHub, Git is one of the most popular version control system, and it's based on the distributed architecture. It is based on the distributed architecture that we have. And that exactly is what GitHub is all about. It is basically our distributed version control system. Using it, we can define, okay, how exactly we are going to store the, now here using it, we can use it as a repository so that we can store it directly to the centralized repository. And again, Git is basically a part of distributed version control system. So GitHub is a repository. Git is basically a version control system, and GitHub is a repository used by Git. It is not mandatory to use only GitHub with Git. We can also assign multiple other repositories. For example, we are using the code commit from AWS as a part of cloud repositories. Then we can also combine those repositories with the Git version control system as well. So that's why we can say Git is basically the tool that is the version control system, and GitHub is the repository where we can allow multiple team developers to continue to store their code, and then if they want to share it, they can also share it as well as part of the requirement, right? So we can say that Git is basically what? Git is the version control system, whereas GitHub is the repository. All right, so next we have what is a GitHub? GitHub is basically a web-based Git repository hosting service. It's easy to manage, it's open source tool, but it also has the enterprise version available. It allows the effective collaboration between multiple team members. And then it can also have a bug track available, which was not from the beginning itself, but again, it has been reduced lately. So basically, GitHub is used as a centralized repository where we can push or pull data from central server, and Git is used to push or pull the data from central server, and GitHub is a core hosting platform for version control collaboration. So GitHub is a company that allows us to host a central repository in a remote server. That is what we have discussed so far. So now if you talk about Git, then Git is basically a version control, a distributed version control system. So when we have multiple teams, now for example, we have multiple developers and they all are collaborating, they all are working on the code development, then they are going to store the code in the local repositories, correct? And once they are done, they can simply commit the code. So when we say we are uploading the code, we simply mean that they are committing the code to the committing changes the source code, and then we simply push that code to the remote repositories. And that's why we can ensure that all the members of a single project, they all are aware on what is happening on the project. They can store the entire files for a project in a centralized location, and then they can track multiple changes done to the same file by using the versioning offered by Git. So if you talk about Git features, then it is economical. That means there are no licensing fees involved here. It's free and open source under the GPL license. Then again, it is non-linear. That means again, there is no sequential path that we have to take as a part of development. And it offers snapshots. That means we can record changes made to a file rather than the file itself. And then that's why it simply makes sure that the entire file size, the entire bandwidth consumption is also low. It is distributed. That means every user will be having its own his or her own copy of the repository data stored locally, so that even if the remote repository is not available, still the users, they can continue to work on the same, and they can start storing the code locally, and whenever the remote repository is available, then they can push the codes accordingly. It offers speed. So speed offered by Git is lightning fast as compared to any other version control system. One of the reason is it doesn't store the entire file itself. It stores simply the snapshot of all the changes being done. And then it is robust. That means nearly every task in Git is undoable. We can undo it. We can come back. We can revert to the previous changes as a part of rollback whenever we need. And then in terms of integrity, no changes can be made without Git recording it. And then we have branching. So every collaborator's working directory is a branch by itself. So for example, when we are working on updating the code, then we can maintain a master branch. And let's say we are looking to apply to work on new features, then we can create a new branch for adding features. When we are working on debugging, we can create a new branch for debugging and so on, so that we don't change anything in the main source code. And once we are done testing the changes or bug fixes, then only we can merge those changes with the main code, so that we can also increase the likelihood of not breaking the code. And if we are doing changes, we can maintain a separate copy as a branch, and then we can start storing the codes accordingly. All right, so in order to understand how exactly Git works, so basically when we are working as a developer, we can add something called as, when we want to work on file, then we can push those files to a staging area where we can work on the file itself. Once we are done, then we can commit those changes to the local repository, and then whenever we are ready, we can push the files from local to the remote repository as well, as a part of the setup defined. So when we talk about staging area, let's talk about what exactly staging area is. So for that, we can come back to our annotation mode. All right. Now we can take the example to understand the concept of staging area. We can take the example for our own working desk. We have staging areas. That means we can understand this by a simple example of our own working desk. We have staging area. Staging area. Let's say when we are working on a, this is our work desk. This is our work desk. Now in this work desk, we have a specific area where now here we have a complete stack of files. We have a complete stack of files. For example, we have 100 files that we have to go through one by one, correct? So practically what we do, we pick one file and then we bring into our work area, and then we open the file, and then we start going through the file here, right? And then once we are done, we then move this file to the stack of completed files, correct? That's how it works. So suppose this is our working desk, right? So suppose here we have a complete stack of files. For example, there are 100 files here, correct? So do we open up 100 files at once and start working? We pick one file, one or two files, or we pick a couple of files, max to max 2 or 3 files at the same time, and then we start working on it, correct? So we pick one file, we bringing into our work area. Now this work area is itself referred as staging area. This is what is referred as staging area. So when we are working on any file here, that means now suppose if we make any changes to these files, that is currently in the staging area. Now this is what staging area is. So whenever we are making any file is available in staging area, so now whatever changes we do on in these files, all the changes are going to be recorded. Every single change is going to be recorded by using this, by having the file in staging area, right? And once we are done making all the changes, suppose there have been multiple changes being done here on this file. Once we are done making all the changes, now we are done with the file. Then we move this file to where? We move this file to the local repository. We move this file to another area where we can mark the files which are ready to be uploaded, and this is what we refer as local repositories, correct? So and here we can say this is a workstation, or we can say workspace. This is our workspace, and then once we bring any files to work, then this is referred as the staging area. This is our staging area is. And once we are done, then once we are done with the file, where we are tracking all the changes, then we can move those files to the local repository, and then we can simply upload the files to the remote repository once we are done. And that is exactly is what a staging area is. And staging area can be multiple. For example, we can have one main staging area. Now for example, for bug fixes, we can create another branch for bug fixes. We can have another branch defined for finding or implementing new features as a part of the staging area as well, depending upon the requirement. Now let's see how we can install Git and how we can configure it up. So Git can be downloaded. So basically here we can install Git Bash for Windows by going to gitscm.com/downloads. So here we can refer to git download. So here we can open up this link, and if you're using Windows or Mac or Linux, we can choose any of the platform that you're trying to install Git on, and this is going to download Git locally. It's an installer, so we don't have to do a manual setup. It's simply a installer, so we can download the package and then we can run it. All right. And once we are done, we would be able to see Git Bash also installed. So let me showcase you. Once we are done, we can open up Git. So here we can simply search for Git Bash once it has been properly installed. So we can open up Git Bash and then we can start using the Git platform here itself. We can let us zoom this in. And now currently we have successfully installed Git, and now we can start working on any project as a part of Git setup. So currently this is what now the entire command set is going to be the same as our Linux platform as well. So here we can simply use the same command set as Linux and then we can get started. So let's start with our discussion on Git. So first of all, we are going to now when we want to work on Git, first of all, we have to initialize Git. We have to initialize Git so that we can once we start working on any of the codes that is going to be present as a part of the project, each and every changes done on those files can be tracked by Git. So let's do one thing. Let's create a project folder first. So for doing that, we can make use of a command such as mkdir. And let's say we make a project by the name of suppose web app. Web app. A simple project folder. Now let's do one thing. Let's switch to this folder by using cd web app. So currently we have switched to this particular folder. Now we want to initialize Git in it. For example, if we open this up in our file explorer, now currently we can see here we have a folder by the name of web app and currently it is blank. So in this blank project folder, we are going to include multiple files as a part of our folder structure. For example, suppose here we are going to initialize Git. So let's do one thing. We can come back to our Git bash. And to start with the Git, here we can use Git init. So basically when we use Git init, a simple Git repository is going to be initialized in the directory that we defined here. And currently we are working on the master branch. So now if we go back to the folder, we can see a Git folder has also been added here. We can see a Git folder has been added. If we double click on it here, on this folder, we can see all the Git files have been initialized in this empty repository. Now, let's do one thing. Let's add some files to it. For example, let's say to work on a project, we can create a simple static HTML page. Let's say here we can use any of the core editors to create a simple page, a simple HTML page for us. Let's say here we save the here first of all, let's save the file in the same folder that we have initialized. So under users, username, and then under web app, let's save this file as suppose home.html. So let's create a simple HTML file here as HTML head. We can define a title as welcome. This is our home page. And then we can close title, we can close head, we can open up body. We want everything to be placed in center. And now we want to add simple h1 as welcome to suppose Edureka. We can close h1, close center, we can close body, and then we can close HTML. So let's say we have a simple HTML file that we have added in the same folder where we have initialized Git. So we have home.html available here. Let's create another file. Let's say here we save the file as suppose contact.html. Let's say we use the same structure, but we make some changes as in suppose this is going to be our contact page. We can say contact us. And then the heading should suppose include contact us. And here we should include suppose something in h3 as support@edureka.co. Suppose here we have these two pages with us. We have contact.html and then we have home.html as a part of the project structure that we have defined. All right. So here we have say these two files with us. We have home and then we have contact. Now let's do one thing. Let's come back to our Git bash so we can start working on these files. Now currently we have two files, correct? Currently we have two files. So first of all, to see the status of the files here, we can use git status. So basically using git status, we can see which file has been added to the staging area and which files are not being tracked, which file is being tracked. So for getting the status, we can use git space status. So you can see here currently we are working on master branch and there have been no commits yet. And these two files, content.html and home.html, these two are available in the same folder where we have initialized Git, and these two are not being tracked. That means if we make any changes to these files, then these are not going to be tracked at all, correct? And that's why we have to make sure that we do add these files, or we can add both the files to staging area, or we can add one file and then we can start working on it. For example, let's say we want to add only one file out of two files in the staging area. So here we can use a command git add. So to add the files to staging area, we can use commands such as git add, and then we can specify. Now, for example, if we are going to add all the files, and here we can specify all as all, or if we are going to specify just a single file, then we can specify the file name. For example, we want to add home.html only. We want to add only a single file. So here we can define git add, and then here we can define home.html, correct? That means now if we specify home.html, then this file is going to be added to the staging area. Now, if we start working on now we start making any changes to git add home.html. Now these changes are going to be tracked by Git. For example, if we go back to our editor, for example, currently we can come back to a Sublime text, and in here we can go to home. Now this home page is what we have added, correct? Git add home.html. That means this one has been added to the staging area, correct? So now if we make any changes to the file here, for example, let's say, okay, we have mistyped this welcome, right? So now let's say we make this change, and let's say here we add one HR as well as horizontal line. And then, for example, just these changes, for example, just these, or let's say here we also add H2. We are learning Git. So now what we had done, we have changed the spelling of this welcome, then we have added HR, and then we have added one more line for H2, and then we define the content for it, right? Now if we save it, once we save the file, now to see the changes, now as we have added the file here, now to see the change, first of all, if we go to git status, now we will be able to see the same changes are going to be, the status for the file is going to be reflected. We can see if we go to git status, we can find these are the changes committed to the file here, correct? And again, we can see this file has been modified because currently it is being tracked by staging area, and this file is still not being tracked. This file is not being tracked here, and that's why we can see this is what is being currently displayed as a part of status. Now to to see again what exactly has been the difference. For example, now currently we want to see what exactly has been the different changes, or how one file compares to the previous file. Then we can use the output as get difference. Then here we can define get difference to see how exactly we can make the changes here. Now to see what exactly is the difference of files here, we can use get difference. And now get difference, what it does, it simply shows the changes done to the current file which has been added to the staging area. We can see now in staging area we have only one file by the name of home.html. Now we can see that this version has been currently added. Now whatever we can see here in red, this one was available earlier, and whatever we can see here in green and with the plus sign, we can see these are the ones that has been currently added. So minus is what, when we remove any of the single element or the entire line, and plus means these lines were added as part of the changes. For example, now let's say we do another change. Let's say here we add another HR, and suppose we remove this one here. And now if we save it, if we come back, again, if we use get difference, we can see the same thing has now been updated. We have simply added the space here, and plus this new element for HR has been added. So every change is going to be recorded by the staging area. Once we add the file to staging area, each and every change is going to be recorded, and they are going to be saved as a different version, altogether. Now, once we are done, we can simply, for example, let's say we are done making the changes to this file. So now what we can do, we can commit this file to the local repository. For committing the file, we can use a command as git commit, and then we can now if we have multiple files in the staging area, for example, we would have two files in staging area, then we could have used all, or suppose we could have specified the file name or currently, but here in this scenario we only have home.html. So here we can add home.html, and then we can add a simple message as well along with it. So let's say here we want to define a message as first commit. So here, what now using commit, what we are going to do, we are going to commit this file. That means once we are done making the changes to the file here, so now we can push this file to the local repository, because that is what we discussed as a part of architecture followed by git. This is a workspace, correct? So once we have now from workspace we have added, suppose here we have two files, correct? In workspace we have two files, so we added just one file. For example, this file was added to the staging area. Now this is what staging area is, where we can track all the changes. Once we are done, we have to move the file from staging area to the local repository. So for moving the file, what we do, we simply use a command such as commit. So commit does what? Commit simply moves the file from staging area to the local repository, and then once we are ready, then we can simply connect the local repository or get to our remote repository, and then we can use a command such as push to push the code from local to, we can use push to push the code from local to the remote repository. We can do that. So currently we are using commit. So using commit, we can push the file to our local repository with the commit message. Okay, we haven't configured. I think this is a fresh installation, so we have to first of all configure our account as well, because again, when we are committing any changes here, when we are pushing any codes to the remote repository, then we also have to define the configuration for the for our Git. So currently we have to configure that first. So for configuration, we have to use git config. Now, first of all, we have to define two things here. For global, we have to define first of all email. So here we can define user email, such as we can define, let's say, our own email address. And then we can run another config where we can define the name. So here, instead of email, we can define name. Suppose here, now here, whatever we define here, this is going to be added as a part of the configuration. And now we can run the same thing as commit. So now we will be able to commit the code to the repository, to not to the remote one, but again to the local repository. And now I can see here, this file has been committed. So one file has been changed where there have been 13 insertions, and now the commit has been added here to the local repository. Now, once we have moved the file from staging area to local repository, then we have to move the file from local repository to the remote repository as well, correct? So for that, we have to create an account. We need to have an account on GitHub. So in case you don't have the account on GitHub, so we can refer to something as github.com, and in github.com, we can simply click on sign up in case we don't have the account, or we can click on sign in if we already have the account. GitHub is a free tool, as we had discussed, so we can sign up on GitHub just like any other tool. And once we have signed up, we can log in. We can log into our GitHub account. Now here we can choose any of the repositories that in which we want to push the files, or let's say we want to push the files opposed to our own specific repositories, and here we can define it as part of the requirement. So let's say here we can make use of any of the repositories that we have the access to. For example, let's say we do one thing, we can use one repository that we have by the name of IT. Let's use this one. Or in case we want to start from scratch, okay, let me showcase you how exactly we can start from scratch. So once we have logged into our repository here, we can create a new repository as well. We can click on new. We can define the name. Let's say here we want to call it as November 1st. So you can define the repository name. And here we can keep the repository as public. We can click on create repository. Public means anyone can have the access. And now we have got the repository URL, as in github.com/ this is going to be our username and the repository name. So here we can copy this up. Now, first of all, in order to push the code from local to the remote repository, we have to add and authenticate that remote repository that we have currently created. All right. So here we can now, first of all, we have to add the remote repositories. We have to add the remote repository. So for that, we have to make use of a command such as git remote add, and here we can define the remote repository name. So we can give any name to our remote repository. For example, we can name it as origin, we can name it as suppose ed, or any name that you want to give to this remote repository. For example, suppose here we want to give it a name. So here we can define git remote add, and suppose here we want to call the repository as a suppose as a repo itself. Simple repo. Add repo1. This can be the name of a repository. And then we can specify the path. That means here we have got the link. We have got the link for adding the path itself, right? So here we can define the path of the remote repository that we want to add here. So forget now, in case we don't have the path, then we can come back and here we can copy the path from here. And once we have the path with us, then we can simply define the URL for it. So here we have already copied the URL. And once we enter the URL, we will be able to log in to the GitHub repository. Now, once we have added this, now we can push the code. Now, once we are done, we can simply push the code to the remote repositories as well. Now, once we are ready to push the files here, we can simply use git. We have push, and then we have to define, we want to push the files to our remote repository as repo1. And from where we want to push it, from our master branch that we are currently working on. So here we can use git push repo1 and master. And if there are files available in our local repository, then this is going to first of all get connected to the repo1, where we have to define the credentials first. And then this is going to push the code from our local repository to the remote repository. So as you can see here, this is currently being pushed. And now if we go back to our remote repository, if we go to the section for pull request or the repository itself, we can see here home.html has been currently pushed to this remote repository that we have currently created by using Git. Thank you so much for joining. Have a great day ahead. Take care. Bye-bye.